All right, now let's look at functions. In our previous lessons, we've already talked about the other related concepts, which are relations and mapping. This time, we are going to look at functions. Okay. Previously, I said that these three concepts are what related, and all these concepts, relation, mapping, and functions. Relations and functions and mapping are all having what? Some commonalities. All right, good. Right, we can see that a function and mapping are all what? Relations. Previously, we said that a mapping is a relation. Eh? All mappings are relations, but not all relations are mappings. The same thing applies here. So here too, we see all functions are what? Relations, but not all relations are functions. So in this case, we are saying that a function is a relation in which element of the domain corresponds to only one unique image of the codomain. So here the underlying word is what? Only one unique image of the codomain. What do you mean by unique in the codomain? It means that you have elements in the domain, but they must correspond to only one element in the codomain. We've already looked at the various types of relations, so we can relate here. Okay, good. So what we are trying to say is that we can have single elements in the domain corresponding to only one image of the codomain. The same way, we can also have many elements of the domain corresponding to what? Only one. So here, what we are trying to say is that when you take the two sets, that is the domain and the codomain, for instance, let me use the arrow diagram to explain it better so that you get what I'm trying to say. So let's say we have our x values, which are a, b, c, and then we have our y values. We have our y values where we can have maybe m, p, n. Good. Then we have this function here. Let's say this is our f is the function given. All right, so what we are trying to say is that is where you can have only elements in the domain mapping onto only one element in the codomain. All right, great. We can also have this as well. Let's say we have set A, and then having 1, 2, 3. Then we have set B, and here as well we have, let's say we have 6, we have 9. Okay, and this one also maps onto this. So let's give this function G. So the name of the function is G. Good. We can have elements which are mapping onto. So let's say I have this one corresponding to 9. I have 3 corresponding to what? 9 as well. I have 2 corresponding to 6. At the same time, I have what? 3 corresponding to 6. Now let's look at the first example. You realize that each element in the domain maps onto only one element. So here, I know by now, looking at this diagram, you can tell me the type of relation we have here. Only one element from domain corresponds to only one element in the domain. That's what we see here. So I know that you can say this is what? 1-to-1. Okay, 1-to-1 relation. Now let's look at this. You realize that here too we have 1 mapping onto 9, 3 also mapping onto what? 9. So here you can have many elements from the domain mapping onto only one element of the codomain. The same way we have 2 mapping on 6, 3 also mapping on the same 6. Here too, you can also see we have many elements of the domain corresponding to only one element in the codomain. So this one too, if you see this diagram, know what comes in mind. You can also tell the type of what relation. We can say that this is what many to one relation. Many to one relation. So all that we are saying is that you can have as many as elements in the domain mapping, but they must map onto only one. The moment you have element in the domain mapping onto many elements in the codomain, then it ceases to be what? A function. That's what we are trying to say. It ceases to be a function. All right, good. So that is all about a function. Now let's look at some interpretation here. Let's say, so let me write this notation. If I have this, my x is here mapping onto y. This is a notation of a function. Okay. All right, so let's look at how we can read this one. How do we read this? We can say that what a function f is such that x maps onto what? Y, meaning that we can have a set x from a function, okay, or element from set x which corresponds to what? Element in set y. That's what we are trying to say. Okay, so this is one notation. I can also write the same thing as this. F, I have my x, or let me put the x here, which is equal to what? My y. Okay, so how do we read this? We can also say that f at x, or f of x, is equal to y. Okay, good. What does it mean? It means that this y you see here, it is the image of what? This x. Okay, this y is the image of this x. So this x corresponds to what? This one. This is what? A function. So when we talk of a function, we say the function is a special type of relation, but the element in the domain must have a unique element of the codomain. That is what we are trying to say. Okay, good. Now let's quickly look at the various types of functions. We've already talked about 2 from these 2 diagrams. All right, so one, we can say that we can have a one-to-one function. One-to-one function is the same as one-to-one relation. All right, great. And we can also have what? Many to one function. The same way we can also have another type called onto function. We can also have, there are so many types of functions. Yes, we have so many types of functions. You can also have even function. We can also talk of odd functions. Good. So these are some of the types of functions we can talk about. We have other types, but let's talk about these ones. Okay. And in our next videos, we shall be taking them one after the other and look at what they are. So in the first place, let's hold on for now. All right, so we will come back again and talk about what the various types of functions. Okay, good. So this time, let's look at how we can do the evaluation of what? Functions. Evaluating functions. Okay, then later we can come back to the various types of what functions. We shall take them one after the other. All right, great.